This is the third of 3 videos on the rules of indices. In the first video we looked at multiplying, so when we had the same base we said a to the power of m multiplied by a to the power of n was equal to a to the power of m plus n. We then saw if we divided with the same base, a to the power of m divided by a to the power of n, we subtracted, and this gave us a to the power of m minus n. We then went on to the second video and looked at 2 more rules of indices. The first one was raising to a power. A to the power of m raised to the power of n gave us a to the power of m multiplied by n, or just mn, and a to the power of 0 gave us 1. So these are the first 4 rules that we will use and apply throughout this video. The next one is a to the power of minus m is equal to 1 over a to the power of positive m. So let's go back to the last video. I looked at 2 to the power of 6. 2 to the power of 6 was 64. 2 to the power of 5 was going to give us 32. 2 to the power of 4 was going to give us 16. 2 to the power of 3, or 2 cubed, was 8. 2 squared, or 2 to the power of 2, was going to give us 4. 2, or 2 to the power of 1, gave us 2. And we saw that 2 to the 0 was going to give us 1. So we saw that we were subtracting here. We subtracted a power each time we went down, and we were dividing this side by the base. So we were dividing by 2. Therefore, if I subtract another power, what I'm going to get is 1 over 2, as I need to divide 1 by 2. So in this particular situation, we can see the value of m is 1. So if I wrote now 2 to the power of minus 2, this is going to be 1 over 2 to the power of 2, which would give us 1 over 4. If I had now 2 to the power of minus 3, it would be 1 over 2 to the power of 3, which is going to give us 1 over 8. So that now gives rise to this particular rule. A to the power of minus m is 1 over a to the power of positive m. And hopefully you can follow this pattern and see how it works. So let's go ahead and answer some questions. So from these ones, we can certainly now look at answering the first one. So we'll answer that one. We can do this one. We can do that one. We can do this one. We can look at that one. And we will deal with the other ones shortly. So if we look at this one, we've got now 4 to the power of minus 2. So this is going to be 1 over 4 to the power of positive 2. So this will be 1 over 4 squared, which is 16. If we look at this one, 2 to the power of minus 3, I'm going to write 2 to the power of minus 3 is going to be 1 over 2 to the power of positive 3. So 1 over 2 to the power of positive 3 is going to give me 1 over 8. 6 to the power of minus 1 is going to give me 1 over 6 to the power of 1, which is simply 1 over 6. 7 to the power of minus 1 is going to give us 1 over 7 to the power of 1, which will be 1 over 7. Finally, 5 to the power of minus 2 is going to give us 1 over 5 to the power of 2, which will give us 1 over 25. So nice and straightforward, we're simply writing these out as now a to the minus m is equal to 1 over a to the positive m. Okay, so that's one of our rules. Let's now move on to a new rule. This is the most challenging of them all. A to the power of m divided by n is equal now to what we say is the nth root of a to the power of m. This is really quite, I find the notation quite daunting for some students. What I would prefer to write is a to the power of 1 over n raised to the power of m. I think it's a lot easier to see than writing this particular notation. So what this is telling me is to take the nth root of a number and raise it to the power of m. It will become quite clear once we've done a few worked examples, but hopefully it won't be too daunting. So if we now look at this one right here, we've got 9 to the 1/2 power. The half power is the square root. So I could write this now as 9 to the power of 1/2 raised to the power of 1. This is telling me to take the second root of 9. So what two numbers multiplied by one another give 9? And that is going to be 3. So we can say now that this is going to be equal to 3 to the power of 1, which of course is just 3. If I now look at this one, I've got 64 to the half power, and I'm going to write this now as 64 to the power of 1/2 raised to the power of 1. You might be thinking, well, why am I writing the 1? Well, we might have a scenario, as we can see here, where we have a different number in the numerator. So I'm going to take the second root of 64. The second root of 64 is 8. 8 times by 8 is going to give us 64. So we can say now that this is going to be the number 8, and we need to raise that to the power of 1, which is going to give us now 8. Let's say we had now 64, and I'll write it just here, 64 to the power of 1/3. So I could write this now as 64 to the power of 1/3 raised to the power of 1. What three numbers multiply to give 64? This is asking me to take the third root of 64. That's going to be 4 times by 4 times by 4. So that's going to give me 4 to the power of 1, which is going to be equal to 4. We take now the third root and we raise it to the first power. So you're probably thinking, well, how do you know that the third root of 64 is 4? Are they all going to work out quite nice? Generally speaking, they do. So let's now look and try and push this out slightly and look at 64 to the power of 2/3. So the first thing I'm going to do is write this as 64 to the power of 1/3 squared. We know from the last video that if I multiply these two, I'm going to end up with 2/3. So if I take 64 to the 1/3 power, that is going to give me 4. I then need to square 4. 4 squared is going to give me 16. So if we say now 64 to the power of 2/3 is going to give us 16. So let's have a look at this one just here. This is one of my pet hates. People say that this is a quarter. It's not. What we're looking to do is take the fourth root of 16 and raise it to the first power. What four numbers multiply to give 16? Well, that's going to be 2, and then we raise this to the first power. So if we go ahead, we can answer this one now, because what we're looking for in that particular case is 16 to the 1/4 power raised to the third power. So that's going to be 2, and then we raise this to the power of 3, which is going to give us 8. If we look at 27 to the 1/3 power, and I'll just write this out, 27 to the 1/3 power, we're looking for the cube root, the third root of 27. Well, that's going to be 3. We raise it to the power of 1, which is 3. Therefore, if I had 27 to the power of 4/3, we could write this now as 27 to the power of 1/3 raised to the power of 4. The third root of 27 is going to give me 3. I would then have 3 to the power of 4. 3 to the power of 4 is 81. So we're now looking at some tough questions. If we look at this one, we take the second root, or the square root. The square root of 9 is 3, and then we do 3 to the power of 7, which is going to give 2187. Let's just have a look at that. 3 to the power of 7. 2187, I'm guessing. Yeah, 2187. So that now is 3 to the power of 7. Let's do this one. 25 to the power of 3/2. So 25 to the power, and I'm going to write this as 1/2 cubed. So we need the square root, the second root of 25. What two numbers multiplied give us 25? The answer is 5. I'm then going to raise that to the power of 3. 5 times by 5 times by 5 is 125. So we can write 25 to the power of 3/2 is 125. If we look at this one now, this is quite nasty. What we've got is 8 to the negative 1/3. we're now going to look at combining the two different rules. What I'm going to do, instead of writing this like so as 8 to the minus 1/3, I'm going to write this as 1 over 8 to the power of positive 1/3. Hopefully it makes sense of why I've done that. If we think about 8 to the power of minus 1, this is going to give us 1 over 8 to the power of 1, which we could write now as 1 over 8 to the power of 1. If you want to look at it that way, it's perfectly fine for you to do so. Essentially, all I've done here is written it as 8 to the minus 1 raised to the power of 1/3. That's all I'm saying. It's negative 1 here. So we can write it like so. So I'm combining the rules. So at this stage, what we need to do is take the cube root of 1, which is going to give me 1, the cube root of 8, which is going to be 2, and raise it now to the first power. So I'm going to write this as 1 over 8 to the power of 1/3 raised to the power of 1. So this is going to give me now 1 over 2 raised to the power of 1, which is going to give me 1/2. You might think that's completely unnecessary. I think it's quite a nice way to do it. So here's a really, really nasty one. Let's say we have now 4 over 25 to the power of minus, and we'll write this just here, minus 3 over 2. So the first thing I'm going to do is invert this fraction. What this is saying is 4 over 25 to the power of minus 1 raised to the power of 3 over 2. So if I'm writing 1 over this, I can simply write 25 over 4 to the power of 1 raised to the power of 3 over 2. All you're doing, if you have this particular case, a standard result is 25 over 4 to the power of 3 over 2. I'm going through it step by step, but you can just jump from here to here. You don't have to show this. So what we're going to do now is the following. We're going to have 25 over 4 to the power of 1/2, and then we're going to, and I can use square brackets if I like, cube my answer. So we want the square root of 25, which is 5, divided by the square root of 4, which is going to give us 2. We now raise this to the third power. We're going to end up with 5 to the power 3, which is 125, over 2 to the power 3, which is going to give us 8. So 125 over 8. And that's a really tough question. Okay, let's go on with a few of these. So these are kind of looking at different bits and bobs. We can do lots of different things. I think the best thing to do now is to look at just a few of these. So what's it asking me to do? Simplify the following expressions so that they contain no negative indices. So if we look at this one right here, let's go for this one. This now, we multiply the powers, so we're going to have a to the power of minus 3 over 2. So we can write this as 1 over a to the power of positive 3 over 2. So all I'm doing is using a to the power of m raised to the power of n. I'm multiplying these two, and then I'm rewriting it using now a to the power of minus m is equal to 1 over a to the m. If we look at this now, a to the negative 12 multiplied by the negative 1/4, 12 times a quarter is 3, the negatives will become positive, so this will be a to the power of 3. This one right here, we're going to have now 9 times negative 1/3, which gives us a to the minus 3, so we can say 1 over a to the positive third power. A to the minus 4, and then we're going to have b to the fourth. So I'm multiplying, so this is going to give me a to the minus 4, and then we're going to have b to the positive 4. We could write this as b to the 4 over a to the positive 4, as this is another example now of a to the minus m is equal to 1 over a to the m. This one's quite nice down here. Let's go ahead and write this. So this is going to be raised into the power. We're going to have a to the power of 3 divided now by b to the power of 5. So nice and straightforward, we're multiplying 10 by 1/2 and we're multiplying 6 by 1/2. This one is quite nice. The first thing I'm going to do is write this as m to the 4th divided by a to the power of 2 raised to the power of 1/2. So that's going to give me m multiplying these two, that will give me m squared over a to the power of 1, which we can just write as m squared over a. This one just here, we can write this as c to the power of 6 over a to the power of 8 b squared raised to the half power. You can either see this as multiplying or you can simply see it as the square root. If we think about this, c cubed multiplied by c cubed is going to be equal to c to the 6. In the same way that c cubed raised to the power of 1/2, we multiply these, which gives us c3. So we're going to have c3, we're going to have a to the power of 4, and then we're going to have b to the power of 1, which we just write as b. Okay, let's move on and look at some more. Right, okay, let's see what looks a bit nasty on here. This one, nice and straightforward, 1 over 3 to the positive 2. So that's simply now 3 to the minus 2 is equal to 1 over 3 to the positive 2, which is 1 over 9. Anything to the 0 power is going to give us 1. This one is quite nice. We can write this now as 1 over negative 2 to the power of positive 6. If we have an even power and an negative number, it becomes even. So this is going to give me 1 over 2 to the power 6, which is 64. So if we have an even and a negative, it will be positive. So even power negative number, it ends up being positive. If we had an odd number and this was negative, it would become negative. Just think logically about this. If we have negative 2 multiplied by negative 2, that will give us 4. If we have now negative 2 multiplied by negative 2 multiplied by negative 2, well, that's going to give us now negative 2 times by negative 2 is positive 4, and then multiplying by negative 2 again will give us negative 8. So I did this by the power of 2 and this by the power of 3. Okay, this one we need to invert the fraction, so this is going to be 6 over 1 raised to the power of positive 2. 6 to the positive 2 is 36. 1 to any power is 1, so we would write this as 36. This one is quite crafty. If we look at this, what I'm going to do is combine this and write it as a top-heavy fraction. 1/2 is 3 over 2. So we have 3 over 2 to the minus 3, which we can write as 2 over 3 to the positive 3, and that is going to give me 2 cubed, which is 8, over 3 cubed, which is 27. 9 to the 1/2 power is just going to give us 3. We're taking the second root and raising to the first power. If we look at this one, we need to be a bit careful. We're going to end up now with negative 3. If we take the cube root of negative 27, we're going to get negative 3. This is quite a nice one. What we're going to have is the following. We're taking the square root, so it's going to be 1 over 49. We need to take the square root and simply raise this to the first power. So we're getting into some quite tough territory. So if I take the square root of 1, I'm going to get 1. The square root of 49 is going to be 7. That one's fairly straightforward. The cube root of 125 is going to be 5. The square root of a half power of 4 and 9, well, that's just going to give us 2 over 3. This one is nice, 36 to the power of minus 1/2. So 36 to the power of minus 1/2. We can write this as 1 over 36 now to the power of positive 1/2. Remember, 1 to any power is just going to give us 1. So we want the square root of 36, and that's going to give us 6. Okay, if we look at this one, we can write this now as 1 over 81 to the power of positive 1/4. We're taking the fourth root. The fourth root of 1 is 1. The fourth root of 81 is going to be 3. And we simply raise that now to the first power. The next one here, we're going to write this now as 1 over negative 64 raised to the power of positive 1/3. The cube root of 1 is 1. The cube root of negative 64 is negative 4, and we're just raising that to the power of 1. This one right here, we're just going to invert this fraction, so we're going to write this now as 32 to the power of 1 over 5 over 1, which we wouldn't need to do. We need the fifth root of 32, we're going to have 2. 2 to the power of 5 is 32, so the fifth root is that. This one right here, this is going to give us negative 2 over 5, so it's going to be now a negative number. We're taking the cube root of 8 is 2, cube root of 125 is 5. This one is quite nice, and I'll just do this one here. I'm going to combine these, so making this now a top-heavy fraction, I can write that as 9 over 4 as a top-heavy fraction. To the power of 1/2, we take the square root of the numerator and the denominator, which gives me 3 over 2. This one is going to give me now 25, so let's look at that. That's going to give me 27. So this is 27 over 8 to the power now of minus 1/3. So it's 8 over 27 to the power of positive 1/3. The cube root of 8 is 2. The cube root of 27 is 3. And of course, we're only raising that to the first power. So if this had been the negative 2 over 3, then we would have squared our answer. Okay, let's do a couple more and then we'll move on. So in fact, let's have a go at this one. Take the square root and cube it. So 4 to the power of 3 over 2, we could write as 4 to the power of 1 over 2, and we need to cube it. The half power of 4 is 2. 2 to the power of 3 is going to give us 8. If we look at this one, we take the cube root, so 27 to the 2 over 3 will be 27 to the 1 over 3 raised to the power of 2. Cube root of 27 is 3. 3 to the power of 2. 3 to the power of 2 is 9. The fourth root of 16 is 2. 2 to the power of 3 is going to give us 8. This one right here, we would take the square root of 9 and then raise it to the fifth power. I'll do this one just here. 8 to the power of minus 2 over 3. We can write this now as 1 over 8 to the power of 2 over 3. We take now the cube root, so we can write this as 1 over 8 to the power of 1/3, and then we would square our answer. So this is going to give me now the cube root of 1 is 1, the cube root of 8 is 2, so we have 1 over 2, which we need to square. 1 squared is 1, 2 squared is 4. What else? I mean, all of these are pretty much of a muchness after you've done a few. Let's look at this one right here. So this is 0.04 to the half power. So if we think about this, we could write that as a decimal as 0.2. But what we've got here is 4 1/100ths. So if we think about this, this is 4 1/100ths, which is 1 over 25. We need 1 over 25 to the power of 1/2. So we take the square root, which is going to give us now 1 over 5. So if we do that, taking the square root, which is going to give us 0.2, as we would expect. So if we look at this one, 2.25, we can write this now, lots of different ways that you could write this. You could write this as 225 over 100. If we look at this, we can now divide this. So this is going to give me 9 over 4 if I divide the numerator and the denominator by 25. And that is to the power of minus 3 over 2. So I can write this as 4 over 9 to the positive 3 over 2. So I can write this as 4 over 9 to the power of 1/2. And then I will cube my answer. So we're getting into some quite interesting territory here. So let's go ahead and do that. So if I do that, I'm going to have the half root of 4 is 2. The half root of 9 is going to be 3. We then need to cube our answer. Cubing 2 gives me 8. Cubing 3 gives me 27. So it's going to give me 8 27s. So that really is quite a nice one. Should we finish with, let's just do one more. Let's do this one. So if I combine that one, I'm going to have 25 over 16. So 25 over 16 to the power now of negative 3 over 2. So I can write this as 16 over 25 to the power of positive 3 over 2. I'm going to take the square root and cube. So if we take the square root, so 16 over 25 to the power of 1/2, and then we will cube our answer. So this is going to give me the square root of 16 is 4, the square root of 25 is 5, and we'll cube this answer. 4 to the power of 3 is 64, 5 to the power of 3 is 125. So that is the final answer. So some of these, as stated, are quite challenging, but if you employ the rules and take your time, they're relatively doable. Okay, we're asked, and this is a bit of extension, we're asked to solve each equation. We're trying to solve for x. It might be obvious, the first one, what number to the half power is 6? Well, the answer is 36. The square root of 36 is 6. But what I'm going to do to solve this is raise both sides of the equation by the reciprocal of this fraction. So if we think about this now, if I raise this to the power of 2 over 1, which we can of course write as 2, what we're going to have when we multiply these, we're just going to have x, or x to the power of 1, and that will be equal to 6 squared. So all I'm doing is raising both sides of the equation to the reciprocal of this. So that's going to give me x is going to be equal now to 36. And you might think, well, I knew it was 36, and that's perfectly fine if you're doing easy examples. So on the next one, I've got x to the power of 1/3, which is the cube root. I'm going to raise this to the power of 3. What I do to one side of the equation, I must do to the other. This is going to give me x to the power of 1, which is what I'm trying to do, and that's going to give me 5 to the power of 3, which is 125. If we look at this one now, I'm going to raise this to the power of the reciprocal. The reciprocal is going to be minus 2, and that now is going to give me 2 to the minus 2. So I've got in here minus 1/2. When I multiply this, it'll give me x, or x to the power of 1, and that will give me 2 to the power minus 2. So we can say x is 1 over 2 squared, which is going to give me x is going to be 1 over 4. Now to pluck that figure from just looking at it is a lot harder, and that's why I'm suggesting using the reciprocal. So if we look at the next one, we've got x to the negative 1/4. I'm going to raise this to the minus 4, or if you like 4 over 1, and that's going to be 1/3 to the power of minus 4. That's just going to give me x. I can invert the fraction to write this as 3 over 1 to the power of positive 4, and that's going to give me 3 to the power of 4, which is 81, over 1 to the power of 4, which is just going to give me 1. This one right here, I'm going to write this as x to the power of 3 over 2. I'm going to raise this to the power of 2 over 3, and that will be equal to 8 to the power of 2 over 3. What I do to one side of the equation, I must do to the other. So if we look at this from here, that is just going to give me 1. Multiplying the reciprocal by the fraction gives us 1. We take the cube root of 8, which is 2, and we square the answer, which is 4. So hopefully you can see now why I've opted for this method. The next one, we're going to have x to the power of 2 over 3 raised to the power of 3 over 2 is equal to 16 to the power of 3 over 2. This is just going to give me x to the first. We take the square root of 16. The square root of 16 is 4. 4 to the power of 3 is 64. If we look at the next one, we're going to have x to the power of 4 over 3. We're going to raise this to the 3 over 4, and that will be 81 to the 3 over 4. That's just going to give me x. The fourth root of 81 is 3. 3 to the power of 3 is 27. If we look at the final one, we've got x to the negative 3 over 2. So x to the negative 3 over 2 is equal to 27. So I'm going to raise this now to the power of negative 2 over 3. Raising this one to the negative 2 over 3. I'm going to get x is equal to, and I can write this now as 1 over 27 to the positive 2 over 3. We're going to take the cube root, so this is going to give me 1 over 3. We then need to square our answer, so x is going to be 1 over 3 squared, which is 1 over 9. Hopefully now you can see exactly the reason we follow this particular method for the harder examples. I can't really guess that off the top of my head that that's going to be 1/9. Simply solving an equation will help us. So there's a bit of extension work. So we've looked at the 6 rules of indices now and combined them in a final video.